Hi, my name is Alexander Commodore, and I'm going to be the instructor for this Python Fundamentals course. If you have no experience in a programming language at all, in fact, that is actually desired. Why? Well, Python is one of the easiest programming languages to start with. And the best part about this too is we're going to teach you everything you need to know to start making your own programs and to start with a logic structure that is going to make sense and apply to all other programming languages. You see, when you start with one language, it actually makes it really easy to learn others, and it all is a matter of understanding logic and understanding how to apply things. And this can be done in both Windows and in the Linux operating system too. So you can access Python from anywhere. And in the next two videos, we are going to show you how to install and set up Python in Windows and in Linux. So I'm super excited to get started with you guys, and I'm really glad that we can offer this course for free as to help provide support to cybersecurity awareness and to get more people interested in cyber opportunities. So with that, let's get started. Okay, so how do we install Python in Windows? Well, first of all, we're going to look up Python on the internet, and we are going to start installing it from there. And we are also going to explain what are integrated development environments and how do we use them and what options do we have. Now, the ones we're going to look at are idle and PyCharm. And we're going to use, I'm mostly going to use idle probably. I'm most comfortable using idle. I don't need the additional functionality of PyCharm. However, PyCharm offers a lot of benefit to it, especially with the user experience. And you probably want to use PyCharm actually. So what we'll do is we'll type in idle Python, and we will go to, let's see, download Python right here, python.org, and then download Python 3.11. And as that installs, we are going to open the file, install now, say yes. So we're just going to install Python traditionally. So we're going to accept the changes that Python wants to make, and that is going to take just a little bit of time. While we're letting that happen, we can start looking at PyCharm, and we can go to download PyCharm, and we can download the free version right here. And I'm going to go ahead and put the PyCharm and idle links into the resources of the video, so it's very easy for you if you prefer to find it that way as opposed to looking it up. Okay, PyCharm is good to go, so now we'll open that file as well. Okay, PyCharm is starting to install, and Python itself is finishing up a little bit. So just click next, 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 all the way through. And just start letting both of those install. There's not a lot we have to do to actually get going with this stuff. So the Python setup was successful, and we still have PyCharm going. And if you see this, just go ahead and close it. Accept any of the changes. Oh, we're actually already going, so here we go. We got this going. Now that Python is installed, you can search Python in here, and you'll notice you have idle. So you can go ahead and click that. Alright, awesome. So this is what idle looks like. This is our integrated development environment. So this is where we can start typing with Python and how we can start working with it. So you'll notice right away that it has this little sign right here, this like operator sign. That means you can type there. So you can actually start issuing commands in Python right there. That's a real-time shell. How do we use this? You can click File, New File, and you can type anything you want here, and then you can save your file, right? And then press Run, and you can press Run Module, and that's going to output whatever our program's intention is right into the real-time shell, so we'll get a response. And so that's how idle works, and it's quite simple, and you'll see us using it very frequently, so it'll become very easy to pick up on. So let's go ahead and run PyCharm as well. It's finished installing, and we'll click on Finish. So now we don't need these web resources anymore. So we can just close those. And yeah, we'll confirm the usage of this. We don't need to send anonymous statistics. So this is our separate integrated development environment. And the really cool thing about PyCharm is PyCharm actually points out the errors in your code as you're typing. So if we do new project and see, it wants you to save the location of this, so it would go to users, Alex, and then PyCharm projects. We'll just go ahead and click create. So it's loading up, and as soon as that finishes, we can immediately get started with that. Okay, so it looks like it finished installing. So this is what PyCharm looks like when you have it installed. It has a sample Python script for you to look at where it talks a little bit about some stuff, but this is more or less what it looks like. You type in here and then you can press play, and as soon as you press this green button, it's going to say, "Hi PyCharm." So that is an example of not only our first program, but also two options you have in this process for learning. So if you like how PyCharm looks, you have that option of using that. And you can get this in Linux too, and that's going to be in the next video. But if you like the traditional idle, where it could be print hello world, press run module, okay. And we'll save that as a random name. And it's going to say hello world in the shell. So this is how idle looks, and this is how PyCharm looks. So go on ahead and make whatever choice you want as to whatever your preference will be for learning the fundamentals. And in the next video, we are going to discuss how do you go about using Python in Linux. Okay, so this video is for my Linux users. So if you're one of those Linux users, then this is how you get started with Python and Linux. Now we're going to show a couple things. And if you're not a Linux user at home, or if you're not used to using Linux, no worries. I actually teach a course that you can start if you want to, Linux Systems Administration and Security. So if you go to my course profile on Udemy, you can see that course right there. If you're interested in learning the ins and outs of the Linux operating system, how to administer and secure it, that is your golden opportunity. So with that out of the way, if we open the terminal up and we type Python 3 on a traditional Ubuntu image, then it opens up a shell for us. So if you're a Linux user, this is how you can in real time, start doing some commands. So you'll see if I do this simple command right here, we get some feedback. Now if we want to get a little different with it, we'll quit out of that, clear it, and we can do sudo apt-get install Python, or sorry, no, not Python, idle. And then we authenticate that. Okay, we have idle installed already. If you run idle, then we can get what we have in Windows. And so now you can do the same thing. You can actually run commands in real time here, or you can make your own files and run them right here. So those are the two ways which you can do this. Now there's one more way, and we'll remove this file here, nanofile.py, and we start the top with user bin python. Now we will do some ambiguous Python command, save that, and we will change the permissions on that Python file. You'll notice it is green right now, and we can do python 3 file.py, and that is going to work. So your options as a Linux user, and there's way more. You can do PyCharm on this too, but this is good enough for the case of all the options you get in Linux. So your options are Python 3. Your other option is idle. And the third thing you can do is natively create your own files and then run them with Python against the file. So again, if you're not a regular Linux user and you want to learn a lot more about Linux, then go on ahead and check out my instructor profile and get started on learning Linux. It's a great opportunity. Most servers and cloud computing solutions run on it, and a lot of cybersecurity jobs ask for Linux as one of those skills. So if that's something you're interested in, go on ahead. If you're a regular Linux user, then you know exactly what I was doing in this video. So if you're not in that category, Don't worry, it's okay. So we're going to primarily be working in Windows while I write Python. So in the next video, we'll get started with some Python things. Okay, so we are going to start with creating our first program in Python. The way we're going to do this is by opening up idle. You'll notice that I have idle opened up on the desktop already. So we have this shell right here, and we can tell that that is in fact a running shell because of the 3 greater than signs right here. You'll see if we type help, it returns something in return, some feedback here. So that is telling us that we have an active shell we can work with and run Python commands in. On the left, I actually went on ahead and clicked on File and then New File as to open this little notepad over here. And so that's where we can actually start typing information in Python, and then we can run it from this tab here where it says Run Module, and that is what's going to execute our Python code. So how do we start by creating our first program? Well, if we think about the conventional means of executing our first program, we typically say hello world. So to do this in Python, to make a print statement, we would do print, and the syntax is this: print, then you have a open parentheses, quotation, and then anything in the quote inside of the quotations is a string, and this is text that is going to be printed out when we execute this command. So hello world, and close the quotation and another parentheses. You need to make sure that you always end with parentheses and have your string in quotations. What's inside can be malleable a little bit, but always the parentheses beginning and close is necessary in order to not get syntax errors. So now that we have a technical first program here, let's go ahead and run module. Click OK, and we'll give this a Python name, and you'll notice that it actually says hello world there. So that is our first program. Now what else can we do beside print statements? Well, we can actually go on ahead and define what our program does. Now it's very simple and we both understand this. Now if someone else came over here and had to understand it, if they didn't know what a print statement was, they really wouldn't. But how do we make sure that if someone else was to look at this, that they could figure that out for themselves? Well, we can comment in Python. Likewise to other programming languages, the way we do it in Python is with a hashtag. So if we put a hashtag there, you'll notice that my hashtag is red. The text here in green is a string, and these commands, we'll just call it, right, is just purple right here. But hashtags are always red, and red are comments, so at least in idle, keep that in mind. So we can type anything after this, and it's only readable by humans, so it's human readable text. Computers can't actually go ahead and see it. So anything that I type after the hashtag is not going to be ran by the computer. So this is a comment, and then we can say, what is a print statement? A print statement echoes back to the user, printing out whatever it is told to the terminal. Basically what happens. So if we go ahead and click run with this, you'll notice it just says hello world. So our comments are not read by the machine, only us, only human readable. So now we know how to make print statements, and we know how to document our code. So now someone else could walk up to this and say, okay, I kind of get what the functionality of this program is, right? And we could kind of just say, if we wanted to as well, the program is meant to just say hello world, right? And so there we go. What else can we do? Well, we can define some variables. So what is a variable? A variable is basically a placeholder, we'll say, for something else. So if we make a variable over here in the left, name, and then make it equal to something, name is equal to, let's make it a string, Alexander, then we have the variable name, and inside of name is Alexander. So that can be called upon later, basically. So we can use variables to hold strings, numbers, input from a user, that we can define, so we can accept user input. So anything someone types into the keyboard, that can be stored in a variable too. You can do a lot of things with variables. You can even do math in variables, but we'll get to some of those other things later. So we have name is equal to Alexander and age is equal to 17. And I'm not 17, but we'll just say 17. So age is equal to 17. And notice there's no quotations around that, and that is because this is an integer, and an integer is a whole number. And this is a string. Now you don't have to, but I like to put a little space after the hashtag. I feel like it looks a little cleaner, easier to read for me. And we'll just put right here, this is a print statement. There we go. And we'll just get rid of these comments up here. We don't really need it. Okay, our variables. So here you go. This is an example of how you would document something, maybe. And we have a variable name here that holds a string of Alexander. And we have age is equal to 17, and that is an integer, which is a whole number. So what can we do with those variables? Well, let's run this, and we will notice right away it says hello world, and we don't get any information as to our variables, right? Now we can use print statements to actually print our variables. So if we do print name in parentheses and click run, then we will see hello world Alexander, and it's on a different line. Okay, so keep that in mind too. We can also do print age, and this is going to run hello world Alexander 17. So you'll notice that when we print the variable name, it prints out the contents of what it's holding. So you think about the context of that, right? Variables hold something, a number, a string, other stuff, right? When we print out age, the same thing happens. 17 is returned. So we are going to use these in different ways in the next video, because we are going to talk about string concatenation. So we're going to think about how we put those things together. So now we are going to learn a little bit about string concatenation. String concatenation more or less is adding strings together and using variables within strings. And then we have the odd occurrence of when we have, you'll notice our age variable here being equal to 17, an integer, using integers in strings as well. Now that can't traditionally be done, but we can actually force it to do so with a particular method we are going to use. So we have some information here. Hello world 17 and Alexander. Well, we know Alexander's 17 years old, so let's go on ahead and make a string where we demonstrate that. So first, let's start simple. So let's do this. Print, and then parenthesis with quotation, and then we'll just say Alexander is plus, and then we'll just say 17. Okay? So this is the simplest way we can do something like this if we're adding two strings together, basically. It just says Alexander is 17, and I accidentally put a space in there that shouldn't belong there, so let's run that again. So cool. Alexander is 17. How else can we do this? We could do it like this. Print name plus is 17. Click run module. So we get the same output, but notice this time we used our variable in our string. And the reason why this cooperates well is because Alexander is already in quotations. It is a string and it's not a number. So we're allowed to just conventionally say name plus and then another string, and it adds together. Now notice when you add strings, you're using the addition operator right here. So everything you want to add, we're going to use a plus sign. So let's get a little fancier here. So print, and then we'll do name plus age. Now I'm not going to click go ahead on this because it's not going to work. And actually I'll just show you why it won't work. So let's do run module. Now notice it says str not int to string. Basically, the issue is because this is equal to an integer, it's not going to allow you to actually concatenate it together with other things. So the way we fix this is str being wrapped around age, and so that converts it to a string. So now if we run module, it just says Alexander 17. Now we can make that look better, so let's go on and do that. Let's just get rid of the hello world while we're at it too. So we can do print Alexander plus that. So let's do plus is plus str age. So we're converting age into a string. Okay, so let's just put a note here, and we'll put str wrapped around an integer variable will convert an integer to a string. Cool. So let's click run module, and you'll notice it says Alexander is 17. Awesome. And I didn't put a period at the end of that, but if you wanted to add that, boom, there you go. And it's correct, right? So we can do run now. And there we go, it's finished. So we have 3 different entries of the same thing, except now we are using the number itself, and we converted that to a string. So we can make this look even better probably. So we could do like stuff like hello and then space plus name plus, so that will say hello Alexander, and then we'll do you are plus string age, that's going to say you are 17 plus period. So hello space right here to make sure it makes grammatic sense, because you'll notice when we add our name variable, there is no space here and there's no space there. So because we don't want it stuck together, we got to add the spaces where it makes sense. So hello Alexander, you are, and then we have our converted integer here to a string. So that's going to come out as a string. You are 17, and then we have our period at the end. So notice there's a plus here, a plus here. If you get rid of one of those, let's say you forget one, it's going to say perhaps you forgot a comma. So if that happens to you, just keep in mind that's probably something you did somewhere along the way. So that should work just like that. Hello Alexander, you are 17. So that's how you add strings together, convert an integer to a string so you can add it together into it as well, and how you concatenate things and begin working with things. So in the next video, we are going to talk about how we can do this, but now we're going to accept some user input, so we make it a little more interesting and interactive with the user. So now we are going to discuss taking in inputs from the user. So this kind of entails, we are going to be prompted with a sentence asking us a question or for some information, and what we're going to do is respond by our keyboard, and it's going to store that in a variable for later use, and we'll get to decide how we use that information. So that's quite a cool function and very important. So let's go ahead and just start with either removing this stuff or commenting it out. At least that's what I'm going to do, and I'm going to reuse these names for the variables, so I'm going to comment those out too. So the input function, how do we use this? So first let's do name is equal to input, parentheses, what is your name? Then we'll do age is equal to input what, or we'll say how old are you? Yeah, how old are you? Now notice I put a space after each question mark. That's because we're going to be typing on the same line the question is asked, and I want to make sure that we aren't slamming words together, you know what I mean? So we click run, you'll notice it says what is your name, and my cursor appears right there. Perfect. My name is Alex and I am 23. So notice nothing happens. Well, that is correct. Let's do print name, print age. Now let's run it again, and you'll notice this time My name is Alex, I'm 23, and it says Alex 23. So we are able to store our own information into those actual variables, asking for those user inputs. So that's very cool. So let's get rid of this print name age. So if we think about string concatenation now, and what we were doing before, we can actually go ahead and print hello plus name, and we'll do another plus. You are plus age plus years old. Awesome. Let's try it out. So now we do run module. I am Alex. I'm 23, and it says, hello Alex, you are 23 years old. Perfect. So that is an example of how we take inputs from a user and store into variables, and how we can now add that in order to do our same string concatenation, but this time we are actually replacing that fixed variable with something we created. And we can put anything in there, so that's very cool. And you're going to see how we can use this too in combination with a lot of other logic controllers later. Okay, so now we are going to be doing some simple math in Python. We've already used the addition operator, and that's been, very useful for our string concatenation. So we'll type operators here. We have plus, we have minus, we have division, we have multiplication, we have exponents, we have divisible, I believe that is the divisible sign, modulus operator. So the modulus operator is used to find the remainder when a first operand is divided by the second, and I believe that is all we really need. So excellent. Addition, subtraction, division, multiplication, exponent is 2 of those star signs, and this is the modulus. So we will actually just go ahead and comment out all that other stuff. These are our operators. So we can do some simple math, such as in the terminal, like 10 plus 10, and it comes out with 20. 10 times 10, 100. 10 minus 10, 0. 10 divided by 2, and that is a 5. And we can even use the exponent. We'll just do it like that. It's the exponent of 2. And we can do that modulus. Right. So we can do math in the terminal and get real-time results right away. We can also use variables like val1 is equal to 10. Val2 is equal to 10 as well. Why not? And then we could do result is equal to val1 plus val2 print result. So we can do that as well. And we get a 20. So notice we can store integers in our variables, val1 and 2. We can make one variable equal to the whatever we want to do to it and print it. So we can just change that to multiplication as well, and we get 100. So that's a very simple way of how we do math. Now we can also do things like this, like other operators, like greater than, less than, greater than or equal to, less than or equal to. We also have not equal, equal, and that covers that, yeah. So what else can we do? Well, we can find out if something is true or false. So val1 equal val2. Run module. So that's true. 10 is completely equal to 10. And we can do not equal. Run. And you'll notice that is false. So we can detect true and false statements, and this is one way. We can also do greater than or equal to. Run. At least one of those things is true. It is greater than, or it is equal to each other, right? We can even do less than or equal to. also true. So we can kind of see how some of those operators can be used, and you can think logically how they might be applicable with certain things you want to do with math, and identifying if something is true or false as to weigh that later. So that is how we use operators and some math in Python. Okay, so now we are going to discuss lists in Python. And this is a way in which we can store information, kind of like a variable, to be called upon later and organize data. We are also going to discuss how we count in Python. So first, let's start with that. So we count in Python from 0, 1, 2, 3, 4. So we start with the number 0. So 0 is a real number in Python. And the first item in a list is always referenced with 0. So if we want to call upon that item, we are going to have to say, okay, we're going to reference 0 when we start programming. So let's go ahead and make a list, and we'll see together how that 0 thing works. So we can do storage is equal to bracket bracket, and inside of this is where our information in our list is stored. So kind of like a variable, we have a name and it's equal to something, except because it's within brackets, that's exactly what identifies it as a list. So we can do M16 A4, we can do MRE, we can do 1775 and 556. How about that? And each item is separated by a comma in a list, and notice you can have whole numbers, integers, strings, and this is a new one, a decimal, which is also referred to as a float in Python. So we got our list, and our list is storage. If we want to print our list, we could just do print storage. So that is very similar to how variables work. And you'll notice right away, it prints it all out in blue right here, and the string goes from double quote to single quote when it appears, and our numbers are here as well. Okay, so let's go ahead and comment that out, and let's talk about how the math works, how those numbers work. It's not really math, but anyway, we can do my list is equal to storage, and then we do a bracket, and let's put 0 in there, and then we'll do print my list. If we do run, you're going to notice that M16A4 is pulled out. So when we start counting, if we look at it, that is 0, this is 1, this is 2, and this is 3. Because again, 0 is a real number in Python, and the language starts with the number 0 as 1, technically. So if we did 1 to prove it to you, you'll notice that when we run module, MRE happens. We do 2, you will notice that 1775 happens. You can also do -1, and check this out. You get the third place over here, so you can actually count backwards as well. And we can even go through a range of numbers such as 0 to 2. When we click run, what do you think is going to happen? So this one's interesting. When we press run, this might not have been what you expected. Because this is the number 2, and I said 0 to 2. Well, it's going to start with 0, and it's not going to include 2, but everything before 2. So that's a weird concept, so keep that in mind if you're using Python with lists. That is something you need to make sure you know. So that is kind of how we can start creating lists and start calling out the items of it. And notice we call out a range 0 to 2 by putting a colon as a separator. And that's the only time we're really using a colon, right? But here we have commas separating each item, and we have a blend of types of things actually in our list. So that's kind of how we can start using lists, how you start counting in Python, and some of the cool things you can do with lists. So in the next video, we are going to discuss what are dictionaries and how do those work. Okay, and now we are going to do another type of data structure, and this one is a little bit similar to a list and how it's implemented and used. This one is a dictionary. So we get to associate two pairs of information together, and we are able to call on one in order to get a result out of another. So I will demonstrate. We will make a dictionary over here. let's call it student, and we'll do student is equal to curly bracket. So everything we type for a dictionary is actually going to be inside of curly brackets. So we can do quotation, and then we can put something like name, colon, and then the key pair that would be associated to would be like, how about Brian? And we'll put a comma, and then we have a key pair association there. This is the key pair. This is the value of the key pair. And then we can do, how about age, 23. We can do course, how about this, course, and then we can, course, and then we can do biology. And so we have our dictionary here. So then we can do print student, and this should print the whole dictionary. Run module, and you'll see that it prints out the whole dictionary, kind of similar to how a list worked. And then we can do delete that, and then bracket, we could do name, and we'll put that in quotes, and that's going to call upon that key pair value, and we get Brian. And then we can do the same for age, run, and we can also lastly do course, run that. And that is an example of how we can create a dictionary, store some information, how we see two key, like a key pair and a value together, and how we can kind of call upon all that information. Okay, so we have some stuff written in our left window, and now we can start working on functions. So we're going to take the information in the left, and we are going to let it sit inside of a function, and we are going to look at how functions work, how they get called upon, and if they're not called upon, then whatever's inside of the function does not happen. So a function basically stores information to be executed, and when the time is right, we can call upon it, and that's how we use it. So let's go ahead, and we will just make a my function. We'll do def my function, and then you'll notice right over here it tabs over 4 times. It's 4 spaces generally, or just 1 tab, and we are going to put inside of it storage is equal to, let's just copy and paste it actually. We'll take all of our stuff and just copy and paste it right in here, and we'll make sure all of that tabs over. Alright, cool. And we will let all of those go ahead and run. We just want to get it all, let me see. Tab, alright, we'll get it all on this line because that's the proper spacing and alignment, and make sure that is the case for you because you need proper spacing and alignment. And then we'll do my function. Now when we do run, it's going to do all those things. Now watch this, we'll comment this out, and nothing happens. Now if we do print, you can see the function didn't run. And when we put run, you'll notice the function didn't run. Now watch this. If we do run, the function ran and it did all the things in here. Okay? So that is an example of how you create a function and how we use functions. And keep in mind, the most basic usage of functions is to store a bunch of stuff so that when the time is right, we can call upon it to execute correctly. Okay, so now we are going to talk about if statements. And we are also going to talk about elif and else. So you'll notice in my terminal, or well, yeah, my little notepad over here, not the terminal, but in my notepad, I've written a summary of what if statements are, elif and else, so you can check that out on my screen anytime. So what is an if statement? So if something is evaluated to be true or false, if something is evaluated and it happens to be true somehow, do something else. All right, and we define what that something is. And or elif, I like to read that as or if, because it's always evaluated second. It kind of goes if, or if, and you can have a lot of elif statements. So if, or if, or if, or if, right? And then else is anything else. So it's kind of like error handling. So I'll give you an example right here. If 10 is greater than 5, print, this is a true statement. It should happen. Anything else, print, error handling. Now we click run. Check this out. This is a true statement. It should happen. And well, if we check it out, the logic, what it's evaluating in our if statement, if 10 is greater than 5, okay, that's true, then do this. And anything else is going to print error handling. So let's say if 10 is equal to 5, and we evaluate that with an equal, and variables, we would evaluate like one equal sign. So name is equal to 5 makes sense. For a variable, we wouldn't do name equal 5. We just do equal. So only in if statements are we using equal. So if 10 is equal to 5, this is a true statement. It should happen, right? Well, this is not true, right? So 10 is not equal to 5. So in reality, this would now be a false statement. Because that's not a true statement, it's going to do something else, anything else, and it's just going to print error handling. So if you spend time and you're playing around and doing these things on your own, and you do this on your own and put in some other numbers and see how it makes sense, you should notice how this works. So now we can evaluate another thing. Check this out. Elif 10 is greater than 5, print, this is the true statement. And this one's going to happen. So run module. This is the true statement. Now, it's a little hard to tell which, what we're getting, but we know because we wrote it, so it's fine. But if 10 is equal to 5, that's false, so it's not going to happen. It skips over it to or if, right, elif 10 is greater than 5, so this is the true statement and it prints it. And then else, for anything else, print error handling. So if these were both false, if it was like if 9 is equal to 5, which is also wrong, and we do run module, error handling. Cool. So that is an example of how we can use if statements in Python. And how else could we use it? We could do like if, we could do like, let me think here. Name is equal to input, and we will say, let's get rid of this stuff real quick. All of that. Okay, so name is equal to input. What is your name? And then we'll do if name is equal to Alex, print welcome Alex. Yep, and then we will do else, print goodbye. So let's try this out. What is your name? We'll do Brian. I'm Brian. So it says goodbye, but if we do this again and we click run, what is your name? Alex. And it says welcome Alex. So that's pretty cool, right? So we use an if statement to evaluate if my name matches the name it is looking for. And if it does, welcome. If not, goodbye. So any other name other than Alex exactly, it's going to say goodbye. So that is an example of how we could use an if statement in reality as well. Okay, and now we can look at the for loop logic controller. So how does a for loop work? Well, I like to think of a for loop like for every time something happens, do something, or for something and something, do something. It's kind of just like thinking about it that way, almost like an if statement, but not exactly. So let's look at one example of a for loop. So we can do for, okay, there we go. For I in range, and we will do 101 because it counts from 0 to 100, right? Print I. Actually, let's not do that. That's a really big number. Let's do 26. Run module. And so it prints out from 0 to 25 all those numbers, and we get a number range. So that's an example of how the logic of a for loop works. And I, we can change that to anything. So for numbers in range, so you can kind of define what you want that to be called, the I. The I is just the traditional placeholder, and that's like the logic controller of that part of the loop. And then we typically follow in with an in, and then we define something there. So you could also do things like, let's comment this out. There we go. And then we will go to for I in, how about the word banana? Print I. And let's actually just put for letters. That's what we'll call it. Notice it prints out every single letter from B all the way to the last A. Let's get rid of that, and then we will do something using a list. So my list is equal to, let's say, apple, comma, oops, did not mean to do that. Okay, apple, comma, banana, comma, pear. And then we can do for I, for item in my list, print item. And remember, we're just calling this whatever we want. Run. And it prints out every single item of the list. So that is an example of how we could use for loops and how the logic kind of works. You can change the information you're putting in, and I'd encourage you to check out, especially for these logic statements like if statements and their variants and for loops and so on, go on ahead and find examples online and see what you can do and challenge yourself. So what is a while loop? A while loop, I like to think of it as while something is true, do something. So we can start making while loops by doing this, for instance, while 10 is greater than 5, and that will always be true, so that would be an infinite loop. So be aware of this. If you have something that is true and no way to end it, it is going to be described as an infinite loop. So while 10 is greater than 5, print, and this is going to do it a lot, apple. And I'm going to use Control C in here to get it to stop. But notice, if I were not to click Control C, then this would have kept going forever because it's never going to be untrue. So what can we do to get a looping statement to no longer be true? Well, we can do I is equal to 1, while I is less than 10, print I, and then we could do I plus equals 1, and we can just get rid of this. So check this out. So what do we have here? We have a variable named I, and I is equal to 1, and we are checking while I is less than 10, print I, so it's going to keep on doing this until it reaches the number 10. And looking at I plus equal 1, that's kind of like saying I is equal to I plus 1, but typically in programming you can shorthand that by writing I plus equals 1. Okay, so now we will go ahead and run this. And notice 1, 2, 3 all the way up to 9, and it stopped when it got to 10. If we wanted to get 10 numbers printed out, we change that to 11, and we would do it again, because Python has some weird things to do with ranges and counting. But basically we can use while loops to evaluate logic and see while something is true, continue doing something until it becomes false. We can even create an infinite loop purposefully to ensure that we have something running all the time too. So go on ahead and again check out some challenges and check out some information online as to how you can learn about while loops and what kind of things you can come up with. Okay, and now we are going to evaluate the and, or, in, and not logical operators. So if we take a look at the note space on the left that I have here, you can notice that I defined some of those for you. So when we're evaluating and, we're checking to see if two things are true. So both items we're evaluating against have to be true in order to get a response. When we're using or, we're trying to see if one or the other is true. And if one or the other is true, we'll go forward with whatever the statement is. And in, we're looking to see if something matches inside of something. And not, we're trying to see if something does not exist in something. So let's take a look over here. Let's start with and see what we can do. So if 5 times 2 is equal to 10, and 10 times 2 is equal to 20. Oh man, why is that happening? Oh, it's because of the space here. Okay. Okay, here we go. Print. How about success? Run. All right, success. And why is that? Both statements are true using and. You'll notice 5 times 2 is in fact 10, and 10 times 2 is in fact 20. Now how about this? We'll change this to a 10. Watch this. Let's actually put some error handling here, and we'll print failure. Run. You'll notice it says failure because both of these aren't true. The first one is, and the second one is a failure. So if we put 20 back there, you'll notice we evaluated it correctly. Now we can do this. At least one must be true. So this will be for or. So 5 times 2 is equal to 10. All right, cool, that's true. Or 10 times 30 is equal to, I don't even know, we'll just do that. How about that? Cool. And then we'll just copy over the success failure stuff. Awesome. And let's just fix that spacing issue. So now we can run this module. Oh, and we got to make sure we put that equals to have correct syntax. So check it out. We have the success from before over here, and we have a success over here as well, because at least one of these is true. All right. So if we change this to 100, now both are false. Watch this. Our next statement is going to say failure right here. So notice that it's looking to see if something is true or false, and depending on how it goes, that's the direction it's taking. So that's how we get to use these logical items. So what I'm going to do is comment this stuff out because I don't want to continue seeing a bunch of success failure things as we go. And math is really good for checking out and understanding the logic of this stuff. But we're going to step away from math for a second because we're going to do something else. So how about this? We are going to use in, and we're going to do this. Storage is equal to, and M16A4, and we're just going to put an M16 in there. That's all we're going to have in storage, all right? So we will do if M16A4 is in storage, print we have it, else we don't have it. So let's do this. Run, and it says we have it. Now let's see, how about we do a M18 if M18 is in storage. We don't have an M18. Cool. So that's how we use the in operator. Now we can also do this. If M18 not in storage, print checked, don't have it. Anything else, print error handling. So we'll do, and these work kind of similar depending on what you're trying to do with them, so keep that in mind. But we will keep storage right here, so run. Checked, don't have it. So if it's not in storage, print checked, we don't have it. Anything else, error handling. So what else can we do with this? Let's see. So we notice here we did in, so we checked to see if something was in fact in something. We did not. We checked to see if something is not in something. So that about covers actually the logic operators of and, or, and, not. So yeah, excellent. So go ahead and give these a try. Go put in some math, create some lists, create some dictionaries, check against, whether you have things, whether you don't. If the logic checks out, see if you can do some examples of and or, and check the logic and make up for some success, some failure. See which way it goes. And that should give you excellent practice as to understanding the basics of the and, or, and not functions. Okay, so we've just finished the introduction to the Python fundamentals course. Thank you for joining me and participating in this course. It's a great objective of mine to support awareness with cybersecurity, IT, that whole industry, and helping people find an interest and see if this is in fact going to be a catalyst to them transitioning to that. Now, if you're interested in other course material of mine, you can check my instructor page and you can see that I teach a Linux systems administration and security course, and I also teach one for Windows. So if either of those interest you, I highly encourage you to go to my page and sign up for those courses, because you will be very satisfied with the material and it will teach you a lot and add value that you're looking for to increase, your productivity and what you bring to the table in a cyber operations team. And with that, thank you again for participating, and until next time.